Welcome to Do the Math America. I am Charlene, the Math Shaman.
Page 97 and 98 of the beginning algebra book have some word problems on ratios and percents. I suggest you print out a copy of this textbook using the link in the description box below this video for the PDF file of the textbook. There are several problems that are well worth spending the time working out on your own. You can copy down the problem and then work out the problem and compare your answer with those in the book. I will demonstrate a couple of these problems to get you started. The ratio of the number of boys to the number of girls is 4 to 3 in a class. There are 24 boys. How many girls are there in the class? Start by writing down the facts of the problem in a way that's clear so that I can think about it. So I write down 4 to 3, and it's 4 boys to 3 girls. And there are 24 boys, so how many girls are there? This is a ratio and a proportion problem. So the number of boys to the number of girls is constant. You can think of this as 4 is to 24 as 3 is to what number? What number we will call x. So now we have our equation. 4 over 24 equals 3 over x. We just need to solve for x by cross multiplying. So we have 4x equals 24 times 3. Now I start by multiplying 24 times 3, and I do that calculation on the side. 24 times 3 equals 72. So I continue the problem by writing that out on the next line. 4x equals 72. Now I isolate x by dividing by 4. And whatever I do on one side of the equation, I must balance by doing on the other side of the equation. So 72 is also divided by 4. So 4 divided by 4 on the left-hand side of the equation equals 1. 1 times x, which leaves x by itself on the left-hand side of the equation. And on the right, I have 72 divided by 4, a calculation that I will do on the side. 72 divided by 4 equals 18, so now I have x equals 18, which means there are x equals 18 girls in class, and I box my answer. The ratio of the lengths of 3 sides of a triangle is 3 to 4 to 5. What is the length of each of the 3 sides if the perimeter is 96 meters? Whenever we have a word problem like this, it's best to start out by drawing a picture of the problem. So I draw a triangle. Somehow it's helpful to use a straight edge when we draw our figures, because we can tend to see the problem more clearly that way, and then we can think more clearly about the problem. Okay, now I've got my triangle drawn out, and I will label the sides 3, 4, 5. A 3, 4, 5 triangle has a right angle. We haven't discussed this before, but it just means that one angle of the triangle, one between the sides that are length of 3 and 4, is 90 degrees, or those sides are perpendicular. The 3, 4, 5 triangle is used all the time in construction. Carpenters use it to square off areas, because if they measure out a triangle, sides having a ratio of 3 to 4 to 5, they always know they have a 90-degree angle, which means that the sides 3 to 4 will be perpendicular. The perimeter of a triangle is defined as the sum of the sides, or the distance around this triangle. So you add up the sides of a triangle to get its perimeter. The ratio of the lengths of the triangle has been given as 3 to 4 to 5, and I write that down so I have all the facts of the problem in front of me. We will label x as the variable. Since we haven't discussed algebraic expressions before, this will seem confusing at first, but it will become clearer in our upcoming lessons. We label the sides of the triangle as 3 times x, 4 times x, and 5 times x. So now we can set up the equation as 3x plus 4x plus 5x equals 96, adding up the sides to get the perimeter. This is an algebraic expression, and I will be discussing these in more detail in my upcoming videos. Since 3x, 4x, and 5x are like terms, we can combine them to make 12x on the left-hand side of the equation equals 96. Now we solve for x by dividing both sides of the equation with 12. Left-hand side, 12 divided by 12 equals 1 times x, so we have x by itself. And on the right-hand side, we have the fraction 96 over 12, and I will factorize the numerator and denominator using the shortcut division method. Another way, of course, to simplify this fraction is just to divide 96 by 12. So now I've factorized the numerator to be 2 times 2 times 2 times 2 times 3, and the denominator to be 2 times 2 times 3, and I can cancel out like terms. And I end up with 2 times 2 times 2, or 8, in the numerator. So 96 divided by 12 equals 8. Now I plug x back into the sides of the triangle to find the lengths of each of those sides. 3 times 8 equals 24, 4 times 8 equals 32, and 5 times 8 equals 40. So the lengths of the triangle are 24 meters, 32 meters, and 40 meters. I go back and label those values on the triangle figure, and I box my answers. A 20-gallon saltwater solution contains 10% pure salt and 90% water. If 5 gallons of water are added to the solution, what is the new concentration of pure salt? So when we have a word problem, the first thing we should do is draw out a picture of that problem and include all the facts of the problem. This helps us think clearly about how to go about solving the problem. So in this case, I draw out a 20-gallon container with 10% salt and 90% water. So the first question I'm asking is, of those 20 gallons, how many gallons is salt and how many gallons is water? To find out how much is salt, I need to multiply 10% times 20. So I begin by converting 10% into a decimal. I go back to my reference, 100% equals 1, to remind myself that to convert a percent to a decimal, I need to move that decimal point 2 places to the left and drop the percent sign. So 10% becomes 0.1. Now I multiply 20 by 0.1 to figure out how many gallons is salt. 20 times 0.1 equals 2. So 2 of those gallons is salt, and the remaining 18 gallons is water. Now I need to add 5 more gallons of water to the solution, and I add it from the bottom of the container. It's one of those magic containers that grows from the bottom. Despite the nonsense drawing, we can see that we now have 25 gallons of solution. To figure out the new concentration of pure salt, we take that original 2 gallons of salt, which has not changed, and we make it into a fraction with the new total volume of solution, which is 25 gallons. So 2 over 25, or 2 divided by 25. Do that calculation on the side, and I see it works out to be 0.08. Now I need to convert that decimal back into a percent, and I look at my reference on top and I see that to do that I need to move the decimal point 2 places to the right and add a percent sign. So I take the decimal point and move it 2 places to the right to end up with 8, and I add a percent. So the new concentration of pure salt is 8%. And we box our answer.
I hope you found this video helpful. Thank you for joining me at Do the Math America.